Just checking the volume, making sure that it is recording. And now we can go back and take a look at the program that we started off the other day. So I'll go to today's folder and make a copy of what we had the other day over here. You can copy an entire folder, but if you want to copy a folder, you need to supply the -R option, which means recursive. Otherwise, CP will say, that it's a file, it's a folder, not a file, and it will not do the copy. So in this case, we go back to the parent folder, 2012, 0213, MBR viewer. So we want to copy the entire folder here, and now we have it in today's folder. This is also a very crude way of doing revision control. It's not actual revision control, but it accomplishes something similar to that. All right. So here is our program, and last time we were here, and in the homework assignment, we were working on this part. If the signature is correct, no, we're done with that. For each partition, I want to print out whether it is bootable, not bootable, or we have a problem with the flag itself. So we have to report these messages. This partition is bootable, this partition is not bootable, or there's an error. So we'll go ahead and continue with that. And remove the bookmark here because I'm continuing at this point. There's no need to remember, this is where we left off last time. So we just put as here, this partition is bootable. And then this partition is not bootable. Go back to the homework assignment and say, this particular byte is not a valid value for the bootable status. So go back here, and then this time I use printf because there is a value I have to print along with the rest of the message. So 0x% 02x is an invalid value for bootable status. And this one does need a \n at the end because it is printf. It does not automatically append in a file. Yep.
I don't know if your script checks for this, but just for the sake of thoroughness, you don't have periods at the end of the sample notes.
Oh, okay.
Don't know if you care.
It probably I would just make it check for the first part of it.
Okay.
And you want to put your variable in there in your printf statement?
Oh, that's right. I almost forgot. Well, let's say we forget to do it. Let's see what it does. Okay. Well, I don't have an invalid master boot record, so it should not even trigger that. But we want to see whether the C compiler can pick it up.
I think I did this the other day and it crashed. I put two, specifiers and only one variable in a printf and it crashed.
Spoke to the enter wrong.
Well, okay, I'll explain why it would crash. And then how do you
just take out the first N.
Add spelling here. And when you do that, in this case, if you turn on all the possible warnings, if you look at this message on line 19, warning, format %x expects a matching unsigned in argument. And if we go back to line 19, let's see what it is. It warns me. It tells me that something is not right here. So that tells me, the compiler, the GCC compiler, is actually going beyond C itself, and is doing some check, based on this is a printf statement, and this is a format string. In the format string, it specifies, a unsigned integer printed as a hexadecimal number, but I did not supply an argument to actually print it out. It's only reported as a warning because, it's not technically a syntax error. Okay, because most compilers won't even pay attention whether you're using printf or any other subroutine and check whether the parameters are passed correctly. Now, if I actually go ahead and run this program without fixing it, it will probably crash, because what happens is it would just make certain assumptions and say I will grab the next thing as the actual parameter and print it out in hexadecimal. It may or may not crash because in this case it's a read operation, and it will just grab the next item on the stack as the parameter. So typically it should not crash. It will just give you some really weird value to print out. So I'm not quite sure why it is crashing in your case. Yep.
Shouldn't that be a segmentation fault for security reasons?
No, because everything is on the stack, and everything on the stack is accessible to your program. Because it's really hard to separate the parts on the stack that is like a return address or the saved OEBP and stuff like that versus local variables. So that's why when your program is running, it has full access to everything on the stack, and that's why it's not going to trigger a protection error in that case. Okay. But it is nice that the compiler actually warns me about it. I'm going to open up another tab just to run the compiler. Just so that we can, so I don't have to go back and forth. Okay, and then we have another warning. The other warning is on line 39. ISO C90. Well, this one we know already, because it has to do with when I defined the buffer, we were using a const integer to tell the compiler how many bytes it should allocate, and that's kind of a no-no because. Okay, let me show you what line we are referring to here. It's complaining about this is specifying 512, and this is referring to the 512 that is defined one line before that. This is, typically, the compiler doesn't like this, or I should say the C standard doesn't like this, because, what if I change this to something that's more general? In other words, what if I change this to, instead of 512, I can refer to this as a global variable. Okay, let's say there's a global variable k. This is perfectly fine. If k is a global variable, if I have k up here, unsigned int k, like that, this is perfectly fine. Because the fact it is const means that once it has a value initialized, you cannot change the value of that variable. Well, it is technically not a variable anymore because you cannot change it. But this is perfectly fine. But the problem is, in this case, is when the compiler has to generate code to allocate space on the stack, it doesn't know at compile time how many bytes to reserve so that this will work out. Okay, and the way a C compiler works, depending on which assembly programming class you take and from whom, some of you may understand what the problem is, and some of you may not know the problem is. What the problem is. The problem in this case is, what if I have additional variables declared after this? If the local variable buff here has a variable size depending on the value of MBR size, that means the compiler cannot just say, go ahead and allocate 512 bytes on the stack and be done with it. Okay, and as a result, the offset back to the local variables from the rest of the program, they can no longer be static. They cannot be determined at compile time anymore. And that's a big, big, big no-no to the compiler. The reason why we don't have a problem, and it is only reported as a warning in this case, is because the compiler is smart. And the compiler figures out that, oh, this is just a constant. So it has no problem resolving the MBR size on this line to be just 512. But the language itself does not support this or does not recommend this because, what if this is not a constant? What if this is an expression that can change from one invocation of main to another invocation of main? That's the problem. Yep.
So is that to say that in a strict implementation of the standard, that would be a syntax error?
It's semantics, not syntax.
Okay.
Yeah, because it's the semantics that dictates that you cannot have this expression to be something that can be changed at compile time. How many people understand kind of what I'm talking about, why the compiler is reporting an error here?
65%.
65%? Okay. The way I teach my own assembly programming class is, I just explain how C concepts are actually implemented when the program is compiled. So that's why in that class, stuff like this is explained, and also how the program can access local variables, in assembly language. That's also explained. And when you have a local variable that has a variable size, then it becomes really difficult to find out, where are my where are my other local variables, because the offset will change
That makes sense.
all the time. Okay, but for this program, we'll just kind of keep it the way it is right now and not really do much about it. We do have to fix line 19, so we'll go ahead and fix line 19. And and you pointed that out already, that we need to supply a value to print, and it's just really flag, and that's the only reason why we have flag defined up here, so that I can use the same variable again, over and over. All right. So now we are done with that portion. We can now print out the first block, CHS, cylinder head sector address, as da 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 da. And all right. So this is a good time to really go back and look at the partition record, how it is chopped up into the various bits. Let's go ahead and open up a new window just for that. That's the portion that we want to see. And all right. So what we're dealing with now are these 3 bytes. These 3 bytes is the cylinder head sector address of the first block in the partition, and it is the format is as specified. The first byte is just the head number. The second byte actually has 2 components. The first component, the least significant part, is the sector in bit 0 to bit 5, and then the most significant part are bit 8 and bit 9 of the cylinder number. And then we have the third byte being the least significant 8 bits of the cylinder number. So now the question is, how do we deal with this? Well, what I would do, since I have to do this twice, because we have to find out the CHS numbers for the end block also. So I know I need to do this twice. So we should probably separate this into its own subroutine so that we can deal with it and just have the logic simplified, specified once. So we'll go ahead and say process or get, if you want to, get CHS. It will be given const unsigned char. This is the CHS 3 bytes, or the pointer to those 3 bytes. And then what it has to give me are the 3 different numbers. So we'll go ahead and use unsigned int. It's always okay to use something that's bigger than it has to be. So in this case, I'm just going to use 32-bit integers. And because this is C and not C++, I don't have I cannot use pass by reference. I can only use pass by pointer. Pass by reference is a C++ concept. So in plain C, you can only pass by pointer and then dereference the pointer to have the same effect as a pass by reference parameter in C++. Okay, so we have the cylinder number. We have the head number, and then we have the last one is the sector number. Okay, so here comes a big question. Is this really a waste of space as parameters?
Pointers, so.
Exactly. Pointers, a pointer to whatever is really only 4 bytes in the 32-bit system. So whether it's a pointer to an 8-bit thing, 16-bit thing, a 32-bit thing, or a structure that has 2,000 bytes, it doesn't matter. A pointer only takes up 4 bytes on the stack as a parameter. So that part should not bother us. All right, so now what do we do? The easy one, let's deal with the easy one first.
Head.
Okay, we go back here, and the head is easy. So we'll just say, whatever ph points to, we'll now get the value of the first byte of the 3. So it would just be pchs, like that. And I'm actually not following my own rules, and specify the offset to the head and so on and so forth. So I'm actually doing this, in a shortcut way this time. Are there any questions about this line? Yep.
So you're taking a 32-bit pointer, and you're assigning it to something that's 8 bits. Aren't you going to get the following?
It's the other way around.
Chunks.
It's the other way around.
Okay.
PCHS points to an 8-bit unsigned char,
Right.
and PH points to a 32-bit unsigned char.
Right.
So in this case, it's a promotion. You have something that is shorter, and you want to store it into something that is longer.
Right, but you're not going to pick up the following 3 chunks after it?
No, it does not. It actually only
Sign
picks up the
extension.
1 byte, and then it will do the sign extension
Okay.
automatically. It's
Okay.
automatic promotion.
Okay.
Promotion can always be automatic. It's demotion that needs to be explicit.
Okay.
But if you
Do you want to dereference those when you're assigning them right now?
I want to dereference.
Are you dereferencing when you're in that line that you're on right now?
I'm dereferencing PCHS on the right hand side. The asterisk symbol is dereference.
Yeah.
So the right hand side, the value of the right hand side is the value of the 8-bit unsigned number that is pointed to by CHS at this point.
Yeah. So so there's going to be another place in memory where PH points to that's going to have a copy of that.
That is correct.
Okay.
But that's being passed as a parameter. So from here, I don't know exactly where it's supposed to point to. It is up to the invocation or the caller to decide, what pH is
Okay.
really should be. Okay. The next one that is also easy would be, we'll deal with the sector number. Okay, because the sector number is stored in bit 0 to bit 5 in the second byte. So we'll go ahead and deal with that one. So we'll say, PS, whatever PS points to, will now have the value of the following. It's going to be asterisk PCS, asterisk PCHS plus 1, because it is the second byte. But this will give me more than what I want, so I have to use a bitwise AND operation in order to mask out the bits that I do not want. I only want the least significant 6 bits, so that means the bit mask is going to be a 3F. Okay.
Is that?
Yep. go
I'm
ahead.
sorry. Is that easier to use a hexadecimal masker than an integer masker, or does it not matter?
I like hexadecimal because because there's a 1-to-1 correspondence between a 4-bit pattern and 1 hexadecimal digit.
Right.
So the hex digit F is 1111 in binary. The hex digit 3 is 11 or 0011 in binary. There's a 1-to-1 correspondence. You can actually have a 16-entry table to look up. You can do translation in either direction.
So I made it harder on myself by using decimal.
Well, I mean,
Because you gotta
it's up to
translate back
you.
and forth.
Yeah, it's easier to do in your head with the.
That makes sense. Okay.
Yeah,
thank
so,
you.
but it's probably helpful to say, mask out the most significant 2 bits, okay? And then this is the head number. Okay, the last one is the cylinder number, which is the more difficult one. Now, as a more difficult one, it's only because, part of it is in this byte. So in this case, I have to mask out the least significant part of it. So now I'm masking out the least significant 6 bits and leave the most significant 2 bits as ones. So that will turn it into a C0 because the digit C is 1100 in binary. Okay. Now the bigger question is, what is the type of this expression? If you look at the outer parentheses, the question is this specifying an unsigned int, 8-bit, or is it a 32-bit integer?
Does it have to be unsigned so you don't get the sign extension of the bit that specifies sign?
Well, it is important because the next thing I want to do is to do a bit shift by 2 to the left-hand side so that these 2 bits are at the right position at this point. But now the question is this operation correct? I mean, am I going to end up with the correct bit pattern in whatever PC points to? That's the question. Okay. So to answer that question, the first thing is to ask, what exactly is that? It's a hexadecimal number, and from the C compiler's perspective, whenever you specify a constant like 1, 2, 10, 0 is an exception, but if you specify anything other than 0 as just a literal constant, the implicit type is going to be an int. So now we have one int on one side of the bitwise end, and the other side, which is this side here, specifies an unsigned char, which is a bit wide. But the operator, the bitwise end operator, basically says, I need to make sure both sides have compatible widths before I can operate. Because you cannot do a bitwise AND with one side only giving you 8 bits and the other side giving you 32 bits. Okay? So the type promotion is actually going to be automatic at this point, because the bitwise AND operator says, this is a 32-bit integer, I need to make this a 32-bit integer as well. So it would actually make this a 32-bit integer on the left-hand side, and so the result, which is this portion here, is going to be a 32-bit integer. And so this should be fine.
That's how I did it.
And then we have to do an OR, because we have to pick up the least significant byte also. The least significant byte is going to be the easy one, because it is really just at PCHS plus 2. It is the third byte of the 3. Okay. The extra the parentheses in this case is extra. It is not needed. I just want to, make it there so that you know that it is one single thing. All right. So now we have the PCS interpreted, and we'll go ahead and finish up the rest of this assignment. All right. So the assignment is right here. And what we want to do is to say print the first block CHS address as first block at da 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 da. And I'll just be lazy and copy and paste this into here. It's in insert mode already. We can just do this and do the printf later on like that. And of course we have to grab those particular things first. Now here I'm opening a local scope that is not a part of a conditional statement or loop. It is just a scope for the sake of defining local variables. Okay, because the local variables that I need here is only useful within this little block. Yep.
Is the primary reason you're doing that so that you don't have to declare them at the beginning of the enclosing scope?
Correct.
Okay.
It's just that this way I can use different names for different things so that my program is more self-documenting.
I've never seen brackets just used like that outside of a for or switch. I really didn't even know you could do that.
Oh yeah, yep, you can do it. Yep, the curly braces is just defining a block statement, and you can have a block statement anywhere, anytime you want to inside a subroutine. Yep. So it doesn't have to be just inside a conditional statement or a loop or switch statement. It can appear anytime, anywhere within a subroutine.
Would there be any other reason other than trying to localize variables like this?
I'm just using it to localize variables.
So that's pretty much the only other reason you would do that outside of a formal switch or for whatever, would just be to isolate variables?
Yep. Mm-hmm. Because I might have CHS, as in a different context somewhere else in the program, and I just want these 3 particular ones to have a local scope within this portion, so that I don't accidentally use CHS incorrectly, in the rest of the scope. Yep.
And that would mask any previous declarations, right?
That will mask any previous declaration. Yes. So that means, if I had, CHS as global variables or as local variables or as parameters somewhere else, these 3 will override or mask the other ones, so I won't accidentally end up, messing up, something that I need later on. So in here, we'll deal with that later, because we have to call get CHS first. The first thing we have to pass to get CHS is to give it the pointer to the CHS construct within a partition record. So that would just be p part rec plus the offset to the CHS. So technically speaking, I really should define a const, and say CHS offset and add CHS offset to it. But since I'm running out of time, I'm just going to shortcut that, and use a constant here. Bad approach, because if this program is doing something other than a really well-established standard like the MBR and something that can be changed later on, I'm just shooting myself in the foot here using a constant. But since I'm just demonstrating the program and how to get it done, so I'm just going to shortcut it here and probably write a little comment here and say TA, this is a shortcut, should have defined a constant for the offset to the start CHS.
Which is more typing than defining the constant.
Yes.
So even though you've just said that the MPR is not going to change, it is what it is, you still think it's good programming practice to do?
Yeah, because it's more self-documenting that way. So I can just go ahead and do this, as you pointed out. I'm wasting more time to comment and tell myself to do it later than do it now. Yes. So we'll just have CHS offset is 1. All right. So how's that? Actually, it's the start CHS offset. It's not just CHS offset, because there are 2 CHS offsets. So this is just the start.
Oh yeah, because you're going to do the same thing for the ending block.
Exactly. All right, fine. Now we have to give it the addresses of the 3 parameters, C, H, and S here. Now here, is another thing, where I could have improved the program quite a bit, when we get to this part. Because what if I swap, these pointers? What if I forgot the sequence and I say, %H, %C, and %S? Do you think the compiler would say, hey, those are not the same names as, what I used up there as parameters? No, the C compiler would just gladly take it because the types all matched up. They're all pointers to unsigned 32-bit integers. So this is room for improvement. How can I possibly improve this?
Use the offset.
How about using a struct?
Use a struct.
Use a struct. So that means if I wanted to improve this, I can say struct CHS and just define U in 32T CHS in here, which seems to be pretty silly. Okay, and then instead of using pointers like this here, I would just say that this becomes a struct CHS pointer like that. Oh, that's not good. You can see what my problem is here. Pointer to raw CHS. How about that? Okay, that's better. Okay, so now I have to. Okay, so here I have to fix all the references here. All right, this is why I like VI. So we'll replace PCHS with P raw CHS.
What was the +2?
The dot means the current line. So dot +2 means 2 lines from the current line. So that specifies the range of the substitution operation. There are other ways to specify the end too. In this case, I can also specify end curly brace, which means end of scope.
Got it.
Which is cool. Which is actually pretty handy too. And I can do the same thing with PH, PS, and PC. But since they're actually so this becomes H. This is H. And I don't need the dereference anymore because the pointer thing actually does the implicit dereference. Okay, let me just give you the alternative form of how to do this. The alternative form is to dereference PCHS first. And this thing, what is this? What is the dereference of PCHS? What is the type of that?
It's a char.
Struct CHS.
No, it's a struct CHS. So I
Okay,
can
so-
use a dot notation now to refer to just a member of that particular structure. So in this case, it is the
Yes.
sector. Okay. So these two constructs are actually identical. They just look different.
I've never even seen the previous one.
You mean the first one or the second one?
The first one.
The first one?
At least maybe I just never
Okay.
used it. I've always used the second one.
Okay. But they mean the same thing. To the compiler, the first one is kind of like a shorthand of the second one. Okay. So we can do the same thing here. And this is my cylinder. There we go. Now, how is this approach any better than the previous one?
You can't mix them up.
I can still mix them up here,
Right.
but I cannot mix them up when I'm passing the
Oh.
parameters. In other words, I have just reduced the chances of making a manual mistake because I eliminated one possible place to have an error. So that means when I call gets CHS, I also have to use the same convention. Get CHS is used here. So instead of doing this, now I have to do a struct CHS. CHS. Typically, you use uppercase. If you have a type, you start with uppercase characters, and when you use an object or a local variable name, you start with lowercase. So in this case, it would just be the address of CHS. Is that okay so far? And here we have to change this because according to this, all of these are decimal numbers. Because they're unsigned numbers, they all have to be %use. I mean, in your program, if you accidentally used %d, it will most likely still print it out correctly because the range of these numbers do not approach 2 to the power of 31. So we are not going to accidentally print a negative value as a part. Excuse me, I take it back. We won't accidentally print a non-negative number as a negative number because we are not getting to that part of the range of a 32-bit number. But to be correct, you should be using %u instead of %d. Then we have chs.c, chs.h, chs.s, like so.
You don't need to do the arrow in this one?
No, because in this
pointer.
case, it is
Okay,
not a
yeah.
pointer. It is just a local variable, which is a structure. Okay. Any questions? No questions? Well, since I did write quite a bit of code at this point, it's a good idea to save the file and then go ahead and recompile the program. And it's telling me it doesn't like C++ style comments and that has to do with pedantic. One all by itself doesn't really, nag you about stuff like this. It's the pedantic part that gives you this, kind of warning.
What does it mean by C++ style comments?
The double slash.
Double slash.
Yeah. So technically speaking, okay, where are my slashes? All right, fine. We'll fix it. Well, you really should fix the warnings because if you don't fix the warnings, especially trivial ones like this, and it's really hard to kind of go through all the warnings and see which one is important and which one is not important. So that's why you always want to kind of fix things like that. Okay. There may be a way to fix that problem. The other problem that we saw, I'm going to give it a try. See if that fixes the problem. And that one has to do with for bits variable length array buff. Okay. So that's on line 56. I'm going to do one thing and see if the compiler is smart enough and say, okay, I guess it's not a problem anymore. Because I would just do this. I'm going to turn MBR size into a, how do you call this? A static local variable, which means it is not dynamically created. Once it is created, it is always going to be there. And because we're combining static and const, that means once it is initialized, its value cannot change. So we'll go ahead and see if this will fix the problem. Whether the compiler understands that, okay, I guess it's okay now. Nope, doesn't like it either. Okay, we have a problem on line 11, expected identifier or open paren or open curly brace token on line 11. And this is line 11. Oh, okay, there we go. The problem with GCC error messages is it doesn't really quite tell you what the problem is. Not from the human perspective.
Right.
It's looking at things from the compiler perspective.
Or were you missing a paren?
Hmm?
You were missing a parenthesis?
No, I had a semicolon at the end instead of a open. Yeah, I just have extra
Got it.
an extra semicolon at the end.
So that's what it would be nice for it to tell you is extra semicolon.
Right. All right. So we'll go ahead and recompile the program. This time we'll go ahead and run it too. Okay. We still have that warning left. You know, maybe we should fix it at some point, but right now I'm just going to leave it the way it is. And we'll test it with our mbr.bin. The first block is at cylinder 0, header 0. Okay, the last partition is not used, so that's not relevant. The other ones, I think they all look pretty right.
Yeah.
Okay,
1023.
1023, not the 255. All right. So that means our understanding of automatic type promotion is probably right. I used to write compilers, so I sometimes I look at things from the perspective of the compiler and say the compiler thinks there's an operator, it wants to equalize the width of both operands, and if there's a way to automatically promote one side to be the same as the other side, the compiler would just automatically do it.
So if it's compiler dependent, would it be safer to explicitly promote that?
You can always do it explicitly, just as self-documenting code. I was doing this just to test whether it is the case or not.
Right.
I have a pretty good suspicion that it really was the case.
But you would cast it, wouldn't you?
To make this, I understand the compiler well enough that I feel comfortable with it. But if you want to cast it, it doesn't do any harm. Okay, this doesn't do any harm. The only time you will actually do some harm is casting it at the wrong place. In other words, if you cast the pointer first and then do the dereference, then it will do the wrong thing. Let me just illustrate what I mean by that. Okay, let me show you the two versions, the two alternatives. Not alternatives, but the two ways of doing things. Even though they look similar, they are completely different. Okay, look at these two lines. Look at line 12 and line 13. Doesn't they look about the same? We're just changing the location of the dereference relative to the typecasting. But they would do entirely different things. The first one is incorrect, because what this one would do is this is a typecast operator, and the typecast operator has precedence over dereference. So what it would do is it will first recast p raw chs into a unsigned 32 pointer first. So this entire thing becomes a pointer to a 32-bit integer. Then it will dereference it, and when it dereference it, it will actually pick up 4 bytes and interpret those 4 bytes as an unsigned 32-bit integer. So this number will end up as a fairly big number. Okay, it will have the component that we want, but it will also pick up some components that really has nothing to do with what we want to access. So that's why it is important to understand typecasting, because if you pick up the wrong cast or cast it at the wrong place, it will the program looks about the same, but it actually does something that is completely different from what you want. So this is fine, and if you want to cast it down here too, it's the same thing. You want to cast the result after the dereference and not before the dereference. Okay. So little things that to watch out for, just because it's easy to make mistakes like that. But in this case, if you do make that mistake, it's not a big deal because it's very obvious. The program would just show a way wrong number, assuming the other 3 bytes. Well, we know the other 3 bytes are not always 0, so that means it will report something that's wrong. Yep.
So if you dereference and then cast, it's going to promote and extend. But if you cast and then dereference, it's going to pick up extra bytes.
Yes, because in the second case you are changing the type of the pointer. So now the compiler thinks, oh, this is a pointer,
Pointing at
but
a
it's
larger
pointing to
space.
a bigger thing.
Got it.
So when you dereference, it will pick up what the bigger
Garbage.
thing is and incorrectly pick up the extra bytes.
Thank you.
Can you remind me why you thought it unwise to do a pound define at the top for the MBR size of 512? Remember we started out that way and then took it away and ended up using constants later? What was the negative of that again?
That's based, well, to me, it's not a disadvantage, but a lot of people do not like the use of macros, and using macros to define constants is against the philosophy of a lot of professors. At work, people use both ways. It's really just a practical issue. If the program is written in pound define a constant, they will just keep it the way it is. But in school, some professors are very hang up, on using the right concept and the right thing. So some people will go overboard and try to do everything using const.
To me, it seems so much more obvious, that you have that constant and it's at the top and it's obvious rather than embedded somewhere in your code.
The other problem with the pound define is you lose the definition of the pound define in the debugger. Now I have not verified that. It's not too hard to verify that, but I think that is the case. So in other words, let's do that. Okay, we'll go ahead and define MBR size as 512, and we can just leave it here and not use that particular item. Now if I recompile, I didn't have to leave the editor because I got this one. So I have to recompile this time with a -G option, so that we keep the debug information. So when I use GDB, we can kind of see what GDB can see. We'll go ahead and put the breakpoint in, let's say, get CHS. Doesn't matter. I just want the program to stop at some point. Okay. So we run the program. Yeah, it's waiting for the mbr.bin. There we go. All right. So now if I say print MBR size, it doesn't know what it is. Because macro definitions are lost by the time you get into a debugger. On the other hand, the const will still be there. I'm not in the right context to print it out, but in the right context, I would not have a problem with print lowercase MBR, uppercase SICE. So that's one reason why sometimes it's better to use const ints instead of pound defines, is because in a debugger, if you need to know what a constant is, macros will have lost it.
Are you not in the right context because you limited the scope of the const?
Because I'm in the subroutine now. If I picked up the right context, it will still, I should still be able to access it.
Right.
In other words, if I put a breakpoint on line 59 and just run the program again, then I should be able to know what the size, what MBR size is. It's 512.
Nice.
Yep. Okay. However, the problem, with using a const is, the compiler doesn't like it when you use a const to define the size of an array, because, it's just one of those things, the language itself was not well thought out when people, kept changing it. So a lot of the changes, some changes do not work well with other changes. Basically, original features in this case. All right, so getting back to the program, we can try to finish it up. Only a few more steps to go. All right, so here we can, do some more thing. There are two options here. I think they're probably just fine either way. So in this case, I'll just keep it in the same scope here and say nchf offset equals 1, 2, 3, 4, right? So, and we can reuse the structure.
That's cool.
And then we change this to end CHS offset, and then change this to, was it last or end block? Last block, okay. And we'll go ahead and recompile the program, just run it again to see whether it is still correct or not. Looks right to me. Wait, doesn't look right.
No.
Doesn't look right here. this part looks okay. No, this part doesn't look right because these numbers should be sequential. So my program is not working right. Now this is another illustration of why you should run the program again after you make some changes to it. Even though it's very trivial and nothing bad should happen, test it anyway. Just double check.
Did we get the offset wrong?
1,
Is there another byte in
2,
between?
3, 4. I think it's 5. There's 1 byte in between.
Yeah. You might be right.
Yeah, that's the.
Yeah,
That's
partition
5.
type.
The partition type. Yep. So that's why. But it's good because it illustrates, the thing about, checking your program as frequently as possible. It's good because if you keep, for this program, it's not an issue because because even if you get it wrong and you continue to write the program, you can still pick it up because it's really obvious. On the other hand, if you have a program where the value is not printed and is being used by a later part of the program, and you keep working on the program, then the problem won't show up until much later.
That's bad.
That's why it's always good to kind of check your program again whenever you add some code to it, make some changes. You just kind of test it again, make sure the program is still correct. In this case, the scope of CHS is really inside this local block, so we don't really use that anymore after this block. And let's go back to the homework assignment. The first sector at LBA address as first sector, and then the last one. All right, so we are pretty close to the end. So we'll do something similar. And we have to find the offset to those two locations. One is at location 8 and one is at location C, which is the same as 12. So we'll say LBA start offset is 8. Number of sectors, offset is 12. And then with this, I'm going to do something. I'm going to do the trick, basically, since I already know this is using the little-endian standard, and the i386 processor is also using little-endian, I'm just going to recast the pointer and do that trick instead of reading 1 byte at a time, do all the bit shifting, and to get to the 32-bit integer. So we'll go ahead and say printf, copy and paste the quoted part of the message. And then we just have to.
You're probably going to want to.
Yeah, we'll go back in. In fact, Pedantic would actually complain about this too. If you supply parameters without using the format, it will actually say that, well, what am I supposed to do with that? So this will be 08x, because we want it to be 0 filled, and this will be dereference as the last thing, typecast, and where the pointer is. So I almost always do it like this, because I know the structure of what I want to do. Dereference as the last part, typecast, and then specify the pointer. And then I go back in the parentheses to specify what they're supposed to be, instead of writing it all the way from left to right, because I cannot keep track of the parentheses as much as some other people can. So this way I don't have to actually keep track of the parentheses. I can focus on what is supposed to be inside the parentheses. So in this case, this will be the cast operation, uin32_t, and this is a pointer. I'm treating this part as a pointer, and this will be part rec, p part rec, pointer to partition record, plus the offset to the LBA start offset. And then the next line is going to be length equals.
That's cool. So that's what you were telling us not to do in that other situation. Recast the pointer so it grabs more.
Right. But in this case, that's exactly what we
Right.
want.
That's what you wanted.
Yep. sector offset. So I think we are good to go. Well, we'll let the compiler, catch all the trivial stuff. Okay, not a problem. Run the program. It looks about right to me.
Yeah. If I remember right.
Yeah, you just have to kind of match this number, because the length of the first one is this number, even though there's an offset here, but the first sector of the second one should be approximately, this number, and you add this number to this number, that should be the beginning of the next one, and that's about right. I'm not really checking everything, but it looks right to me. Yep.
So can you just real quick hit why you did not have to bit shift? Is it because
In this case?
Yeah.
Because I'm grabbing all 4 bytes.
Right, but
As
it's
a
in
32-bit
little
integer.
Indian.
Because both the MBR specification
Yeah.
and the
processor.
i386 architecture are little endian.
Okay.
If they're not consistent, then I have to do the bit shift operation, grab individual bytes and shift it into the right place.
Okay.
So if I were to do this using, let's say, the ARM processor, which is a big endian processor, I would have to. Is that a big endian processor? No one knows for sure. Okay, the 68,000 processor is a big endian processor. So if I need to have a 68,000 computer to read an MBR like this, then I would have to use the shift operation, because I cannot just recast the pointer and grab those 4 bytes, because the endianness they do not agree. Okay. Any questions about the solution to this program? Now, once I release the solution, you guys can actually download it if you want to. Keep it on your thumb drive if you want to, and or just read it and comment on the program if you want to do that too. So this is becoming like public domain at this point. Every time I teach this class, this is my second time, and last time anyway, I do it differently. So if you compare this to what I did in the last time I taught this class, it's probably different. All right. Any questions? No questions? So now we'll go back to talk about the Linux file system, particularly extension 2. And that's also a big, huge mess. This is from the user's perspective. We can skip that. Basic in, out. Where is it? Okay, let's start with this. Now the assignment doesn't have a due date yet because I have not really assigned it per se. Doesn't mean that you don't have anything to do. Every time we go over something in this class for this particular homework assignment, I would do it using hexdump and some other tools, to illustrate how to get to a particular byte and to verify those byte locations or do some calculations. Once we go over that, you should probably continue to write the program so that your program can do that, just inside your C code. So if you do it that way, we cover a topic, you write the code to do it, I cover some more, you do some more. By the time we cover this entire thing and I assign the homework assignment, you would have 95% of it done already. Okay, so I would definitely recommend people to keep working on this program as I continue to talk about it. All right. So this is important. But I will just go ahead and go to one other slide first, because you at some point you need to be able to test the program, and to test the program you need to generate your own raw file system files. Okay, so I will go ahead and cover this part first. Can someone tell me again what exactly is a partition? If I just say that, hey, this is a partition, without telling you what is the file system on the partition, and just tell you, hey, this is a partition, what is it? Yep.
It's a blank slate. It's a big sandbox.
It's a big sandbox, and it's basically an array of bytes.
Yeah.
Okay. Technically speaking, it's a block device, so it's an array of 512 sectors. Okay. But for the most part, you can look at it as just one big, huge array of bytes. Okay. So that means if I put a file system on a partition, it's nothing more than a particular way of looking at the content of this big block of bytes. Is that okay? Is everybody associating the concept of a partition, which is no more than a pile of paper, with a file system, which is a particular way of using that big pile of paper. It's okay? All right, so we can now continue with this discussion, because the first thing we want to do, the first command here, is a dd command, which is just a handy way in this case to give me a file of a particular size. If you look at this command here, if specifies the input file. /dev/0 is a special file because it's an input file that has an infinite size, but the content are all zeros. That's one way to look at the special device called 0. Okay, if you copy from that device, you're just going to copy bytes of zeros. Not ASCII 0, but the byte itself 0. So this is my input file. It's infinitely large. It has no end to it, but that's okay because DD can specify its own end. You can specify how many blocks to copy. The output file is just a regular file. You can call this file anything you want. But in this case, I call it extension to test1.bin because I might have additional test files for my extension to file system. BS stands for block size, so each block is 4 kilobytes, and count is 1024. That means the file size is going to be 4K times 1K, which means it's what? 4
gig? Is it 4
No. 4,000 times 1,000 is 4 million. 4 megabytes. Okay,
megabytes.
It's not that big. Okay, 4 megabytes.
Would you repeat the BS and the count description one more time?
BS is the block size, and count is the number of blocks. So when you multiply those two, that becomes the total size of the file.
So it's 4,096 kilobytes? Or not kilobytes, but bytes?
It will be 4,096 KB.
Kilobytes?
Is it KIB or KB? Which one is the binary version?
KIB.
KIB is the binary one?
I
So
mean,
this,
they're mostly interchangeable, but the technical one that's supposed to be guaranteed to be to be 1024 based would be KIB.
Okay.
I believe.
all right. So let's go ahead and just run this command and see what it's going to do. Nice thing of this is I can just copy and paste it. All right.
So when you say blocks, does it divide those up somehow, or would block size 4 megabytes?
In this case, it
count
doesn't really
one?
matter. In this case, you can say block size equals 1, and then specify 1024 times 4,096
Yeah. Okay,
as
thank you.
count.
Got it.
Because it's just a regular file in this case.
Okay.
But when you're dealing with a block device, this can slow down or speed up the operation.
Okay.
So now we have a file. So we'll go ahead and use ls-l to look at the size of this file. Okay, it's 4,196,324. Are we sure that this is actually exactly 4,096 times 1024? Let's find out. Okay, 1024 times 4,096 is exactly that amount. This number and this number are exactly the same. BC is a command line calculator. I mean, it's just a handy little tool. Could have done it this way too. I think Echo can do it too. So you can 4,096 times 1024. Yeah. All right. So now we have a big file. But what's the content of this extension to test1.bin file?
Zeros.
They're all zeros. Okay. It's a whole bunch of zeros. How do we know that? Now, it may seem that this is a waste of time, but as you do stuff like this, you are basically exercising the commands that will be useful later on. So it's not a bad idea to keep using all these commands to confirm, every step along the way, what I claim is actually what is happening. In this case, it is the asterisk here means, the rest of the bytes are exactly the same as this sequence here. So basically we have, all zeros.
So you didn't need less. You didn't need to pipe it through less. Is that right? You didn't need to pipe it through.
I did
less.
not need to
Got
pipe
it.
it through less.
I'm just checking my understanding.
Yep, that's correct. So is this really specifying the same number? Looks like we're missing some zeros here. And this doesn't look the way it doesn't look the way it is specified in the other one.
What was that, hexadecimal?
But this is in hexadecimal. But does it make sense though? As a hexadecimal number,
No,
does it make sense?
it's not the same.
Well, let's find out.
Oh, wait, no, I take
Yeah.
it back. It could be.
This is 8 bits, 16 bits, 20 bits, and 22 bits. Okay? So when we specify it the other way, we have 22 bits as well. So they're the same. Because 1024 is 2 to the power of 10. Okay, and 4096 is 4 times 1024. So we end up with 2 to the power of 20 times 4, but 4 itself is 2 to the power of 2. So the whole thing is 2 to the power of 22. When you write it as a binary number, it will be the same as 1 followed by 22 zeros in binary. Okay? But when you convert it into hexadecimal, it is chopped up in chunks of 4, right? So it will end up with, let's see, 1 followed by 22 zeros will end up with 5 hexadecimal digits of zeros, and then the remaining portion is going to be 100, which is 4. Or you can use a calculator
I
to
was gonna say
confirm
I
that.
could use a calculator.
But that illustrates how useful it is to think in hexadecimal because it converts so easily to binary.
Exactly. Yeah, that's why we tend not to use decimal numbers when you do low level programming. We use either binary or hexadecimal. All right. So now that we have this kind of strange new file, how do we make an extension to file system on it? It's actually pretty easy in DOS. I would start with approach 2 because approach 2 is really quite the easy one. Tax scenic route, this is basically highway 1, and this is I-5, interstate 5. We'll use the interstate 5 approach. The interstate 5 approach is going to run this one command here, which is actually the same as the other command, mke2fs. It's really the same thing. So in this case, we control the block size using the dash B controls the block size and dash I for the inode size. So in this case, we have control over the actual file system that we are creating. Let's take a look at this command. This is the name of the command. It is mkfs.ext2. In Linux land or Unix land, the extensions of a file is not important. So you can have any type of extension and it can still be an executable. I cannot remember what dash F stands for.
Force,
Force? Okay.
even if it can't detect the normal parameters of a hard drive, like block
Okay.
size.
And then the dash B is to specify the block size. And this is the device that we are going to create the file on. It's just the file that we created earlier. It's the empty big block of zeros.
So you're not controlling inode size with this command?
No, because the default inode size is fine. Yep. And we'll talk about how do we find out what is the size of an inode. So we'll find that out later. Okay. So let's go ahead and run this command. And the nice thing about this is you don't have to be root to do it. Okay, so we'll copy and paste it. Oh, I don't have that. I don't have that. I forgot to install mke2fs. Or maybe it's a root only thing.
It may just not be
No.
in your path.
It worked fine on mine.
Okay, it's mke2fs. It's in the /bin folder, and the /bin folder is automatically on root's path, but as a regular user, it is not on my path, so I just have to point to it explicitly to make it work. Okay, time to change the notes. Just so that we don't run into the problem, when we try to do this. And I should probably move this one. Go ahead. Wait, too much.
I'm glad I'm not the only one.
There we go. That would be a good place to put it. There we go. All right, so we'll go ahead and edit the document. DD is fine, there's no problem with DD. If you use this approach here, okay, and I'll just kind of add, do the following as root. Yep.
You have to do DD as root anyway, so all the commands would be in your path.
No, DD does not need
No.
root. DD is just creating a file.
Oh, right, because we're not using the...
You can always read from /def/0. It is
Right.
not privileged.
Right.
In this case, we need to use sbin first, and then the following this step needs to be done as root. Okay.
Would it be the SCA that you need root
Yes.
for?
And because, well, let's see.
I was able to do those as a normal user after mounting as root, if that's what you're wondering.
Yeah, because it depends on the default permissions of fake.
I wasn't on the live CD, so it could be different for the live CD.
Yeah, we'll figure it out. No, that's not what I want. I just want to save it. Display. There we go. All right. All right, so we'll just go ahead and change the command a little bit by specifying /bin, /sbin before that, and it's done. Okay. Do you think the file has changed in terms of size? No. All we are doing here, if you look at the first file, the file that we just created, as a pile of blank paper, now the paper is not blank anymore.
Right.
Now it has like page numbers and lines, and stuff like that. It's ready for you to write something on it. So we are just we are done formatting basically. That's the formatting part of preparing a file system. So it's the same as format in DOS. Okay, the DOS command format is basically doing some similar things, but using FAT32 or NTFS. In this case, we're using extension 2. Okay. But it is an empty file system at this point. There are no files created. Everything is just it's just empty. So the next step of this thing here is to mount this file as if it is a real file system, as if it is a real partition. And this is one thing that is really easy to do in Linux. And I think in Windows you can probably do the same thing too, but you have to kind of go through hoops to do it. So we'll go ahead and go through these commands and just to see what they do. This command is nothing more than just creating a folder called fake. Now it doesn't have to go to /media. It's just a standard that whenever you want to mount some extra file system, you should mount it at /media the folder. But you can do it anywhere. It doesn't have to be at that location.
I think you have to be root to mount it at media.
Yeah, I just got a permission denied.
Yeah, but mount itself requires root permission anyway.
Oh.
Yeah, it doesn't matter where you mount it. It's just the mount command itself needing root permission.
So make dir is a mount command?
No, make dir is make directory.
Sure.
So if I go to /media right now, it is mounting a drive. It's probably one of the system drives. But so as root, okay, I'm changing to root permission here. I can go to media and create a new folder. I can just call it fake.
So do you have to be root in order to mess with the /media directory, or no?
You do.
Okay.
Yep. Let's check. Yeah, you do have to be root to create subfolders there. But since I'm root now, I can also run the mount command. Okay, so we are down to this part here.
Oh, right.
So this one actually needs root access already. I should have moved as root, up one line. Okay, what is this command doing? This is also something that is fairly native to people who use Unix, BSD, or Linux, but it is foreign to people who use Windows. What we are doing here is to say, look at this device here, or a file, or something that has a file system in it. In this case, it is just a regular file, that we have formatted to extension 2. So we are saying that, okay, look at this thing, this big file, and I want to interpret the content of this file as a file system. Now, when you interpret something as a file system, that means it has to exist somewhere within the directory structure of your system. And this, so the second part specifies where am I attaching that file system to, so that now from here on I have access to that file system. Okay. In other words, up to this point, yes, we have a file system in the file extension to test1.bin. However, we don't have access to it. It's a briefcase with documents, but the briefcase is closed. Okay, you don't have access to the content inside the briefcase. This means we are opening up the briefcase. We're putting it somewhere on the desk and opening up the briefcase. So now we have access to the content inside the file system.
Is it going to physically move it?
No, it doesn't physically move it. It basically, how should I put it? It gives you a window into the file system so that you can perform operations to the file system itself.
So we could technically have just left it where it was and mounted it in place, but that's just bad practices, or is that not even true?
Well, when you use the mount command, you always have to specify where are you mounting it, because when the mount command, what it does is it always takes two parameters. The first parameter is which briefcase are we talking about? Which box are we talking about? And then the second one is where do you want to put that briefcase on the table when it is open?
But you could have used whatever path instead of /media/fake. You could have used whatever path.
Oh yeah. You
Wherever
can
it
specify
exists.
any folder in your file system that you have access to. Yes, that is absolutely right. You can even specify a folder that already has its own content. If you specify a folder that has its own content already, what this will do is it will overlay the content of this file system and use that to hide the actual content of the folder that you're mounting on. It doesn't delete anything. It just simply means that whatever was there is no longer visible because you have this new file system overlaying on top of whatever was already there in that folder.
And then if you unmounted it, which I assume you can,
Yeah, then you get everything back.
would be back there. Okay.
Yep. So we'll go ahead and try that command. And have I done the Megidor already? Have I done it? No. No? Okay. So we'll go ahead and say Megidor media fake, and then we'll do the mount command. The mount command actually can take a lot of options, but in this case, we'll just do it the easy way and just do it using all the defaults. Okay. Yep.
Now, when I just tried that on mine, it said that it's not a block device.
Was it successful?
No.
Or just give you a warning?
I don't think it was successful. It says mount, and then it gives me my full path name is not a block device. Maybe try -o loop, question mark.
So you might need to take the scenic route.
Okay.
Because the scenic route exactly does that. Is to set up a loopback device. The other thing you can do is to type mount itself, and then see whether it is mounted already.
Okay.
In this case, when I type the mount command by itself, it tells me that this file, which is the file that we created and messed around with, is now mounted on this particular folder, and the type is extension 2. So in my case, I can verify that this is in fact successful.
Right, and mine didn't mount, so I'll take the
Okay.
route. Okay.
That might be a kernel thing. It can also be a mount thing because in this case there's no hidden loopback devices. It just simply mounts the file itself to a certain mount point.
Okay.
What is your kernel version? It might have a be a kernel issue. Mine is running 3.1.0. It's a relatively new kernel, but the instructions was written 2 years ago. So any 2.6 kernel should work too.
Yeah, I'm on 2.6.32.
Yeah, that's really recent. I mean, that's one of the last kernels before they switched to 3. So that should have worked already. So it could be just the mount command itself not doing it.
Okay, I'll give the scenic route a try.
Okay. So are there any questions at this point? No? Okay. So if there are no questions at this point, we'll go ahead and go to that folder. Okay? So we'll go to /media/fake. Okay? Now what you see here under the fake folder is no longer whatever was there originally. Whatever is in here is now actually in the file system that we just created. I'll go ahead and go through all these commands here.
Did your prompt change?
Hmm?
Did your prompt change from a $sign to the pound?
Because as root it will change.
Yeah.
Oh, okay, thank you.
Yep. So we'll go ahead and copy and paste this. Copy, paste. Okay, what I have just done is to create a subfolder in the file system that we just created. And in that folder, I create a file, a regular file called test file. Okay, that's what these two commands are doing. And I can double check. ls lost and found is always going to be there. This is where when you repair a file system and it finds lost chains of files, that's where it will put the lost chains. And then tester is what I just created. If you look at the folder tester, it has test file, which is the file that I just created using the touch command. Okay. So at this point, not only do I have a fake file system using extension 2, I have also created some folders, one single folder and one single file within that file system. So now I have something that I can use for testing purposes, because I can at least say that I know something has to be there. Okay, the question is, how do I get there and see my tester and my test file? So when this is all done, you want to get out of the folder, because otherwise you cannot unmount. If I say unmount media,
It's spelled, you need an N before the M in unmount.
yeah, but it's umount actually.
Sorry. I thought I was so smart.
System administrators cannot spell. Okay, it won't let you do it. Even though I'm root, I should be able to do everything. It says it's busy. It's busy because the command line is now using that as my CWD. My current working directory is /media/fake. So that's why it is in use, and that's why you want to press. You can do an exit, but after exit you cannot umount, because umount means you need to have root access to do umount. So the easiest way to do it is simply to move somewhere else. Okay, it doesn't have to be any particular place, but CD by itself works just fine.
Why would that work though if you just exited, because you'd still be in the same directory anyway?
No, when you exit, you will go back to the directory where you were as user.
Oh, okay.
In this case as user, but in your case would be as whatever user you log in as. So now we can say umount. You can type mount by itself again and verify that last entry is no longer here. Okay, so I have successfully unmounted the file system, and I have no use of root access anymore, so I'm going to exit from SU and now back to my user folder. So does that explain what you just yeah. Okay, so now we have one file called extension2 test1.bin that we can use for the rest of this experiment, because the rest of this class, well, not this class, but the rest of the next maybe 2 weeks or so is all about how do we go into this binary file and be able to get to the directories, get to the files, and so on and so forth, because we want to understand what is extension 2, what is a file system. Okay, and this is the part where having a little bit of understanding of data structure can be helpful, but for the most part, this is not really any real data structure. It's just pointers and looking up a table, and then have some more pointers, look up another table, have a pointer to look up another table. There's a lot of pointers and a lot of tables.
If you never unmounted that, then what would be going on with that file?
It will continue. /media/fake will then continue to be accessible in your system. So if you write to that folder, you'll be writing to the fake file system. When you shut down the system using power off, it will automatically unmount everything safely.
If I didn't unmount it, could I actually access that file and look at it? Or
Oh yeah.
I could
You can create additional files. You can read that file back. You can do everything that you can normally do with a file system, because it is a part of your entire file system, your directory structure at that point.
So unmounting it means, okay, we've
It
taken
is-
it, kind of taken it offline and now here it's.
You are basically unmounting means you're closing the briefcase and you're removing it from the table, which is your directory structure, and now it's just a briefcase that you have, somewhere else.
And if you start it back up, does it automatically mount again?
No. No, this is not a part of the automatic, mounting system. When you have USB devices, it actually has to go through a lot of mechanisms to automatically mount the device. So, in the purest sense, Unix or Linux does not auto mount anything. If you want to auto mount something, you have to specify in FS tab or file system tab. That's where the kernel goes and go like, okay, what am I supposed to mount for this system to start up?
That makes sense.
If you don't specify an entry there, it is just left alone and not, auto mount.
Doesn't HAL handle the USB drives though?
Yeah, HAL does, UDEF does, I don't know what the newest standard is. They keep changing that part of the system. But without UDEF, which is an optional part of Linux, and without HAL, which is also an optional part of Linux, it doesn't do any automatic mounting. All right. Well, we are running out of time. People are going to try to come in here. I'll see you guys next Wednesday because Monday is a holiday. So don't come here because I won't be here.
Do we have? You said it was a practice test. Is it graded?
No, practice.